Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at something that's probably on a lot of students' mind right now, the SAT, and what are some strategies and skills that are needed to do well on that SAT. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight, we're joined by our two SAT masters, Jeff McCullough and Tom Reardon. Jeff co-founded the TI-Nspire super user group with Bryce and Perry. He teaches Algebra 2 and AP Stats at St. Mary's Episcopal School in Memphis. In 2009, Jeff received the Presidential Award for Excellence in Mathematics and Science Teaching, and Jeff also has authored the second edition of the TI-Nspire for Dummies and the second edition of the TI-84 for Dummies books, and he is a co-author of the ACT and SAT prep courses for T-Cubed. Jeff, it's great to have you with us.
Great to be here.
And Tom taught at Fitch High School in Austintown, Ohio for 35 years and has served as an adjunct professor at Youngstown State University for 39 years. As a T-Cube national instructor, he has worked on the development of many things, most recently the transformational geometry activities, the ACT and SAT prep courses. And since 2009, Tom has been working as a senior math advisor for TI, currently working on the Family of Functions video series. Tom, that's exciting. Thanks for joining us.
Good to see you, Mike.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Jeff or Tom using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting the audio broadcast option at the bottom of your screen and toggling that on and off. At this point, Jeff is going to talk through our agenda for tonight.
Well, welcome. We're glad to be with you again. And we're going to do some SAT problems. I hope you're excited about that. Maybe your school, kind of emphasizes that a little bit. We're going to look at some strategies for solving some of these, including solving by hand and also solving with a calculator, right? And looking at things different ways. We're very big on solving problems different ways. And we're going to use the calculator effectively. And also, I think you'll get some resources that you can use with your students. We're teachers as well, so we like, sharing materials, getting some good problems that you can do with your students as well.
Jeff, thanks so much. I can agree with that. I've used both of your materials currently as an SAT prep class, and I'm teaching in school, so I'm looking forward to what's coming tonight. And Tom is going to discuss our expected outcomes.
Okay, so tonight we hope that you see and experience what types of problems are on the most recent SAT tests. Again, like Jeff said, share effective SAT test taking strategies with your students, how to efficiently incorporate technology as a teaching and a learning tool, not just for taking the test, but for preparing for the test, and feel much more comfortable and confident what is on the actual SAT when working with your students.
Awesome, Tom. Thanks so much. Tom, you should have control. Feel free to share your screen.
Okay, thank you. All right, so this is the website that has all of our information, and I think Mike will probably put that in the chat, bit.ly/lowercase SAT-APR06, okay? And I'll illustrate that when I'm finished with my part of it, what's going to be on there. There's lots more problems than we can even share in this hour. So with that, says I can annotate. I do not want to annotate. Okay, there we go.
No.
That's not what I wanted to do. All right, so here's our first problem. Now, I'll warn you, we're not giving you enough time to solve these problems, okay? just enough to get an idea. And you're going to get the solutions all by technology, by hand, as slides. So I want to give you 30 seconds. Give me your best shot in 30 seconds. Coming back in 5, 4, 3. All right, so I'm going to illustrate many different ways here, okay? Several different ways here. And I'll go with what I would call the traditional way first, okay? Linear combination, multiplication, addition method, whatever you want to call it. And so I'm going to multiply the top one by -2, the bottom one by 5, and you can see that the y terms add up to 0, and we get, oh, you got to be kidding me. So if I do this traditionally, yeah, right. If I do this traditionally, I got to find x and y, which are nasty numbers, multiply by 4 and add 3. And no, not going to do that, okay? So there's got to be a better way. So one way is using technology on the 84, okay? There is a solve systems, okay? On the apps, it's under polysimultaneous 2, okay? There used to be a polysimultaneous 1.
That's true.
And I'm going to go ahead and just run that app. And I want the second option on that one, okay, the simultaneous equation solver. So I'll press 2. And I can go up from a 2 by 2 to a 10 by 10, which is wow, okay? So we just need 2 equations, 2 unknowns, all right? So now here is where you have to use these hotkeys along the top. And I want to go to the next screen, so I'll press graph. So I'll press graph. And I'm going to go ahead and type in the numbers, the coefficients, and also the operations. So I need a 3, enter, and notice it goes to the plus sign, and I want a minus sign, enter. And then I want 5y, so I'll type in 5, and it pastes it on top of the 3, and then a 1. Let me just pause just for a second so that those of you, if you're following along, which I would like you to do so. And again, if you get behind, all of these have slides. I'll show you, everything's there. Don't have to panic, okay? 7, I like the minus sign. I'll just type in enter, the 2, enter, and then the 6. And so now this is my system right here, as you can see. And I want to just double check and make sure it looks exactly like what's there, and it is. So I'm going to press the graphs key to solve it because that's the key that corresponds there. I'll press the graph key, and I'm getting these solutions, which I am not thrilled about at all, okay? But I don't have to be thrilled about them, okay? And so what I can do is I can actually store these into a matrix. So I can store the solution matrix, and I can, let's say, store it in matrix A, so that if I need to go back and find it, it's there, okay? So let me just add a page here so we can see that. And if I go to matrices, second x inverse, oh, wait, I'm sorry. I have to leave. Yeah. Sorry, I forgot to get out of here. Oh, by one other thing. I press graph, I can get them in decimals, or I can get them in fractions, your choice. So I go back to the main by pressing Y equals, and number 6 to quit the app. And now when I bring up the matrices and type in for A, there's my solutions right there stored as in case I lost them for whatever reason.
What if you type X, Tom? Can you just try that? I just thinks it's 28.
Yeah, I was hoping it would be okay, but it wasn't.
Oh, it doesn't do
So
that.
those are not connected there. Okay. That app, I really wish it would have been that. Okay.
Yeah.
But it didn't. So like minds think alike, Jeff. I thought that too, and it unfortunately didn't work. So what I do need to do is go ahead and evaluate the problem, which was what, 4x plus 3y. So what I am going to do is I'm going to go ahead and use the fraction template and type in 28 over 29. And I'm going to get out of that denominator and store that for x. And then I'm going to also do alpha xt theta n is how I get the fraction template. You can also get it by pressing alpha y equals in number 1, but I'm not going to. 11/29. And you can get out of the denominator, so you can press the stow key, store, into alpha 1, which is the letter y. Alpha 1 is the letter y. And so now I'm going to go ahead and let me just double check and make sure it was 4x plus 3y. Yes, 4x plus 3y. And it's going to take the current value of x multiplied by 4, current value of y multiplied by 3, do all the nasty work, and we get 5, which hopefully was one of our solutions, and it was one of our options.
Yeah, one thing David said, I thought that was interesting. He was just kind of like, he likes to estimate. So he said, X was around 1, so 4 times 1 is 4, and Y was around 1/3, so that'd be close to 5. And so he just kind of like estimated at that point. Does that make sense?
So you're saying that when I got the 28/29, you mean,
Right.
or
He was
just
like, that's pretty close to 1, so he did 4 times
okay.
1. And then
And this
the other factor was close to 1/3, and so he did 3 times 1/3, and so he thought, oh, the answer is probably around 5. So
okay, yeah. So I will take that. Any kind of So thank you for that suggestion. So there's a Pez left over from Easter. Okay,
and,
thank
and
you.
Valerie has a maybe even she found a much faster way, maybe.
Okay,
She
we're
says
going to
maybe
hold
just
off on that.
subtract. Okay,
We're
okay,
going to
okay,
hold off on that.
okay,
Okay, I'm going to do the technology, and then we'll get to the fastest way.
okay.
Okay. All right. So the other way is I do want to, since we have people who are on Inspire, I want to show you can do this also on Inspire. And so for this one, under menu, you can go to algebra, and number 2, solve systems of linear equations. And it says normally it's 2, and x and y are the variables, so I'm okay with that. And then you just type it as you see them. You don't have to have a template or anything like that. So 3x minus 5y and so on equals 1. Then arrow down to get to the second box. And 7x minus 2y equals 6. And now we've got the system there. Let me just pull that off so they can see that. In case you've not used this pulling off of the screens, on Inspire, there's like an imaginary border around the screen. You just click and drag it off. Or if you are on a smart board, you just kind of use your finger and touch it and pull it off. So I'm going to go ahead and press enter. And there's my solutions. And I can do the same thing I did before. Store this in for x, store that for y, type in it 3x plus 4y, and so on. And so I do have these on the website. So here's the 84 solution really nicely. It numbered what you do in order. And here's what it would look like on Inspire, just by storing in for x, storing in for y. Now, none of those ways are the ways that I would want my students to do it. And Valerie, I'm thinking this is probably what you were thinking to do, the alternative solution. And if you look right now at those 2 equations and look what you're asked to find, I'll give you another 5 seconds to think about that. And yeah, it turns out if you multiply the top one by -1 and add it to the second one, you end up with 4x plus 3y on the left equals 5 on the right. This is using something called structure. And when Jeff and I started studying SAT, what's it been, Jeff? Probably 3 or 4 years ago?
Yeah,
I don't know,
about
a
3
long
years.
time ago. We ran into these problems using something called algebraic structure, where this separates the top students from the next level or the next level, and so on. So this has been a great help, and the SAT people create problems that make you have to do this if you want to pick up time.
Yeah, I mean, I think one of the clues there, they didn't ask for x or y. They said, what's 4x plus 3y? Well, didn't that kind of alert you like, I wonder if there's a shortcut here?
Exactly. Okay. And this comes mainly by practice. We have several practice problems in the things we've got for you. So hopefully, Valerie, that was what she was thinking of.
Yeah.
Either way, Valerie, thank you for thinking of that. Appreciate it, Pez. All right, another one using structure. Let me give you about 15 seconds to think about this one. Go ahead, 15 seconds. right, coming back in 5. So again, I'm going to show you the traditional solution on this one. So many of our students, as soon as they see parentheses, they have to use distributive property. That's just like a rule. And you go ahead and solve for n and get n equals 5/4. And a lot of our students, unfortunately, will jump right on it. And Jeff nicknamed this falling for the halfway answer, where you did get 5/4, and there it is. But we were supposed to find n minus 2, which would be 5/4 minus 8/4, which is negative 3/4. Now, that's still not the best way, okay? I think the best way would be to think of that n minus 2 as a variable. You got 5 of them plus 3 equals 1 of them. So 4 of them plus 3 is 0, 4 is negative 3, and 1 of them is negative 3/4. Again, using algebraic structure. Some of you, Jeff had suggested this to me when we were talking about it. How about use substitution? We do that in calculus. This would be a great place to do this. Rewrite the problem so there's only one variable there with no parentheses, and then solve for u, and it's exactly the same answer. Negative 3/4. So these are the types of problems you do them. If you get them, they're great. Okay, they're great. All right, this is number 38. This is a grid in, meaning there is no multiple choice here. C means you're allowed to use a calculator. Most of the problems can be used with a calculator. So let me give you about 20 seconds to think about how you could do this. And we'll come together in 5, 4. All right, so the traditional solution, how most of our students would do this is, no way am I going to do this. There's no way I'm going to solve this system of 2 equations with 2 variables, get it in standard form. That's just not going to happen. It's not going to happen. Well, I'm glad you thought that was funny, because to even try this would be funny. All right. So the alternative solution, and this is the way I think one of the people already did it, was if you just take those 2 equations and add them, look what nicely happens. This whole second set of parentheses terms add up to 0, and you're left with 2 of these parentheses is 40, so one of them is 20. And then if you substitute, go back in,
Oh, yeah.
20 plus whatever's in the second parentheses has to be 29. It's got to be 9. So the product will be 180. So this right here is the way they would have intended you to do the problem. But if your students are like cookie cutters, I only think one way, and this is a system, 2 equations of 2 variables, this is how I got to do it, they're going to lose time and also more chance for mistakes.
But this was on the calculator section. You could do, I mean, you could actually type that in the calculator, but think about, just because you're not even done once you find C and D, then you got to type in I mean, that's a lot of work.
Right. And Daniel Irving said that you could also use like a U substitution again. All right. And let like one parentheses be X, the other one be Y. So sure. Now I did put this in standard form, because on the 84, if you want to solve this using the system's equations, it has to be in standard form. And then you can go ahead and solve it. And notice I get 46 and 12 for C and D, store them, type in what we want to get, and we get the 180. Okay, so that can be done that way. And if you want to see how it's done, again, it's on the website. So because I'm not showing the whole thing, I'm just, because we just showed this. On the Nspire, it turns out you don't have to have it in standard form, which I thought was kind of neat. You can type in the equations as you see them and ask it to solve those. And it came up with, again, with the same answers. And this time, instead of using X and Y, again, I substituted for C and D. And by the way, notice on here, you can solve for C and D, whereas on the 84, you have to use X and Y.
Yeah, I didn't even think about the fact 84, you do have to have it in standard form. It can't really be fractions.
Right.
Did you try
Right.
fractions in there and it didn't work?
Yeah, it was okay with the fractions. It's just not okay. Notice, see what the coefficient has to be. Has to
Okay.
be a half x minus. I couldn't do that. So,
Yeah.
And that's a grid in problem. So I would have to grid in the answer. Pointing out grid directions, make sure you read those. I'm not going to go over them right now, but it's very important that you read them. Main thing to take away is the answer is never negative. There's no way to put a negative sign. So they get a negative answer, it's wrong.
You know, the other thing to tell students, because I've actually had a friend who's one of his students only filled in the top bar, didn't bubble in the answers. And the SAT does not grade the top. They only grade the bubbles.
Yeah, good
So he
point.
got every
Yeah.
question graded wrong because they never bubbled in the answers.
Yeah, good point.
So that'd be number one. Don't, you gotta bubble in. You don't have to write the things at the top, but you have to bubble in.
All right, so switching gears, getting away from structure. I'll give you about 10 seconds. This one should be a no-brainer for us, but for our students, not so much. So 10 seconds, give that a shot. All right, so for this one right here, notice that A, B, and C are positive constants. That's a key right there. We have to know that. And so one of the things that Jeff likes to do is he likes to put in numbers. So I'm going to say, let's say, for example, the vertex is at -2 up 7, okay? And we know that the leading coefficient has to be negative. It's opening downwards. So this is a possibility for the equation here. And so which of these maps here, okay, would be D? Because A, B, and C are constants. B has to be +2, C has to be +7, and A has to be +1 for this to work. So because it's really the opposite of 1, which is -1. So D is our answer.
And I think C is really tempting. We had a couple of participants guess C. It's just, you know, the A and B, I think, are eliminated almost immediately, but C is so tempting there, I think.
Yeah, and it's because it's worded differently than we usually word it.
Mm-hmm.
That's the issue. So, because we're thinking of this as x minus a -2.
Yeah.
Usually. All right, so even though we can't use a graphing calculator on these problems, we can still teach the concepts with graphing technology. On the 84, you can use what's called the transformation app. And we're running out of time already. So I'm just going to illustrate that app in case you've never used it before. Okay. It's the last app in the apps for the 84 family. Okay. And if you run the app, this will be the screen that'll pop up. Press any key and you'll get two y equals that you can type in and use variables A, B, C, and D as your parameters or the variables you can use. And for this one, I typed in the standard, vertex form. So I stored 1 in for A, 0 for B, 0 for C, just so that when I graph this, I'm going to get standard form. And then how you change this is you use the left and right arrows to increase the values of the variables and the up and down arrows to go between A, B, and C. So this is how you could help your students by using the transformation app. You can let them play with these, change A, change B, change C, and see how those different parameters affect the graph. And again,
Yeah,
those.
I think they have some of those built in. Tom, do you mind just showing that just for a second? You can take some of my time. I need them to see that. Isn't there a built-in problem for that?
Not built in. You have to.
Oh, for some reason you had so you go to apps.
So if I go to y equals, I have to actually type it in.
Oh, okay. I thought you go on the left and it had some built-in equations. Does it not?
Not that I know of.
Okay.
So if you just go ahead and type that in there, and then go ahead and graph it. Thing is, you really don't know what value is in A, B, and C when you start. So that's why I like to store them. Although once you're here on the screen, you can type in and say, I want A to be equal to 1. Go down and say, I want B to be equal to 0. And then down again, and I want C to be 0. and then I can go ahead and increase C by pressing the right arrow and decrease it by pressing the left arrow.
Yep.
So
Tom,
the transformation.
go to
Go ahead.
y just for a second. I thought I remember this. Go left. No. Go left. Yeah, press enter. Go down to no, yeah, click that. You
Oh,
see how
okay.
the
This is,
name's in there?
there we go.
Isn't that cool?
Yeah, that is. So I owe you a Pez dispenser.
Wow, thank you. I appreciate
Next time we'll you Pez dispenser. So there it is right there. And so I can go ahead and down to OK, and it'll paste it right in there already for you.
Yeah.
Thank you. Didn't know that one. I learned something new.
That's great.
So on the Inspire, for those of you on Inspire, if you haven't been using sliders, you can create your own sliders. You just type in the equation, similar equation here. And as soon as you press enter, it says, do you want A, B, and C to be sliders? And you say, okay. And you can just go ahead and start pulling them around. The one thing I do want to point out is if you go down to the attributes, the last attribute will actually show the parameters, the values of the parameters. Strongly encourage you to do that, okay? That way you can actually see the equation instead of having to substitute A, B, and C mentally. All right, another thing on that is Mike said at the beginning, I've been working on the family of functions course. Strongly urge you to go there and test those out, help your students learn from those right there, okay? You can see what equations are there, what examples, videos are right there. Try that out. Now, I only have a couple minutes that I have left. I just want to show you a couple other problems without giving you a chance to look at them, but I just want you to see what's available. So here's one. Units conversion is big on the SAT, not so much on the ACT. So it says which following is equivalent to 40 meters per second. And then you have to decide which one. Notice the calculator is available on all the units conversion ones. Okay. So for this one here, it's a good idea to write your units as ratios, as fractions. So we want to go kilometers over hours, kilometers per hour. And also we're going to start with 40 over 1 meters over seconds. The whole key there is we use what's called the factor label method. This is what most of the science teachers use. Keep multiplying by 1. And so, for example, I'm going to multiply 60 seconds divided by 1 minute. The seconds are here so that the seconds will divide out and make a 1. 60 minutes over 1 hour, 1 kilometer over 1,000 meters, so that when we divide out common factors, you can see what's left is kilometers per hour. Okay, so the units take care of themselves. They tell you to decide how you do that. Okay, so I strongly urge you to teach the factor label method. Some of your students can do it without it, and that's fine, as long as they're successful all the time, okay? Another thing that popped up is they love to talk about interpretation of slope and y-intercept. So for example, this one says a tree at a height of 4 feet was planted. This equation can be used to find out how many years it took to reach 25 feet. What's the best interpretation of the number 3 in this context? And your students want to jump on which one says slope because they're going to be so happy to see slope and they find out it's not there, okay? So this is a big deal. In fact, I've got about 4 problems in here that interpret slope or y-intercept in the context. And it turns out it's the number of feet grown per year. So that would be C. And one of the ways I help the students to see that, again, is to write it as ratios. 3 feet over 1 year times X number of years. The years will divide out and leave me with the height in feet. That's how I can kind of say that. And the last one I want to show, and then I want to show the website. This one, let me give you about 20 seconds for that one. See what you think of this one. This is number 33. All right, so for this one right here, this is one of the things Jeff and I came up with. Think graphically. Think by table, think algebraically, think graphically. And Jeff's going to even be showing some, I think, later, second part of this. So go ahead and label the y-intercept, the 0, 4, and the 5, 0, okay? Calculate the slope, got this, and the y-intercept, okay? And then it says to add them. And by the way, your students, if they've never done this before, they can say, no, my teacher's never asked me to add M and B. No, but the SAT is going to. So by doing a problem a day, you're getting them used to the problems being asked way different than you've ever done it. Okay.
Mhm.
By the way, you can write this as 16/5. You could write it as a decimal because it's a grid in. Okay. So with that, there are lots of other problems that I have. Just they're there. I just want to show you the website real quickly, and I'll turn it over to Jeff. The problems that I have are as a PDF are right here. The solutions are here. Jeff's problems are here. We did an ACT one a couple weeks ago, so we'll give you access to that. We're going to be doing summer workshops. I know, Jeff, you're doing some on Inspire, I think. I'm doing some on 84 and the family function. So those are all there for you, okay? All there for you. And so there's the problems, and you can see there are the solutions. Hopefully you can use those. So contact me with questions. And with that, I'm excited to show you what Jeff's going to be talking about.
And Tom, I just have to say, your website is so professional looking. It's really nice that you made it just for this webinar. I mean, we have our own website. I feel privileged for that. Okay, let's see. Do I have the ball?
Yep, you do. You should be able to share your screen, Jeff.
I can do that.
Looks good.
Okay. Okay, so we are on our, here, get this out of the way here. Okay, so starting with some easy problems, we're gonna get to some real doozies here in a minute, but kind of starting easy here. And I'm surprised, kind of like Tom was surprised by how many problems on interpreting slope and y-intercept there are. How many problems there are in percent on this test, Tom? I mean, you've seen that, haven't you? Where you like, man, they sure love that concept, don't they? So what number is 30% greater than 50? When I work with my students, and we do a decent amount of test prep just in my classroom. I teach Algebra 2. And so like, even before I do that, I think, okay, what answers are the worst answers up here? 30% greater than 50, like that's not a good answer. It's less than 50. This is more than twice. So really, if I'm even just kind of like guessing, it's one of those guys. But what I find with students almost across the board is the typical student will solve it this way in 2 steps. They take their calculator, they do 50 times 0.3, they get 15, and then they add that to the 50 and they get 65, which is the correct answer. I'm happy about that. But I don't think that we teach them, or at least in my experience with my students at the lower grades, we're not usually using, there's a faster way of doing that, or maybe a different way of doing this, but that really kind of builds and is more helpful on other problems as we look towards a tougher version of this question that would help them more. And I don't know if you all do this, but I see Mick says this, is he would teach his students to go 1.3 times 50, right? Times X or times 50 here in this case. And that's going to give you the answer all in one step. And similarly, if you haven't done this kind of method before, let's say that we were subtracting 30% from 50. If that was the case, then I would multiply by 0.7. So 0.7 times 50, and all in one step, you're going to just basically, have it so that, you don't have to do 2 steps to do it. And that kind of thinking there, so if I'm adding 5%, I would multiply by 1.05. If I'm subtracting 5%, I would multiply by 0.95. And if you can kind of think through a problem that way with percentages, it makes the tougher problems easier, and it sets you up for success in a few problems. For example, this one, which of the following represents the positive number n increased by 7%? if you haven't, you might kind of think, I don't know. I mean, hopefully, you think, okay, this one's decreased. This is way too much. But you might be tempted by one of those, and maybe you haven't seen the 1.07 thing before. So this seems kind of, foreign to you, but that is definitely, increasing by 7% using the method I kind of laid out there. And so I would say that's there. Tom, are you there? I just want to make sure everyone can hear me. Can you all hear me?
Yep, you sound good, Jeff.
Okay, just make sure. I can't hear Tom, and so I was just usually I can hear Tom, and so I was thinking that. Okay, let's go to the next problem. Again, I kind of started out a little easier here, and then we'll work our way up to some real doozies. Josh, go ahead and try this problem for about 30 seconds here. There are a lot of words there, that's for sure. So when it says flat 15% of 4,000, so in that case, we really don't want to add 15%. We want just 15%. So 0.15 times 4,000. I don't know if you all do this with your students. I sometimes will have my students, when I tutor and when I'm teaching test prep, I want them usually to write down what they're going to type in their calculator. I don't know if you do that or not, but I think it's good for them to do that. I think it's really good when they're doing like, squaring a negative number. Do they put the parentheses in the right spot? If they just type in their calculator, they may not be thinking about stuff like that. And so I really like them to write it out first and then type it in their calculator. And then we're going to take whatever that total is and then do an additional 20%. So this is where we get to use our method here. So you could do 1.2 times that. And that just might be a little bit faster way of getting the answer than multiply by 20% and adding it. Of course, I think it ends up being 720, as some of you said. But just the idea of kind of writing it out. Just a little tip I use with my students. I really like them to be able to do that. And then,
Hey, Jeff, could we just go back to that one real quickly, the previous one real quickly?
sure can.
One of the things I noticed on there is if you add the 15 and 20%, take 35% of 4,000, I think it's letter D.
Oh yeah.
And they're out and the kids will think they got it, okay, when in fact they don't. So always make sure they realize, yeah, the
Right. I mean,
distractors can be really good.
with percentages, you would think if, let's say 1 year your stock goes up 10%, and then the next year it goes down 10%, a lot of students think, oh, like you're back at the original starting price. But you're really not, because you took 10% of, say, $100, if you put in 100, and then you're subtracting 10% of $110, if that makes sense. So you're not going up and down by the same amount year in the stock market. You actually, if you go down 10%, you have to gain more than 10% the next year. So percentages, riches in general, can be very tricky, like as you're saying, for sure. Try this one. I teach algebra too, so I've taught about compound interest here, but this is a good one for students. Okay. Okay. I'll try to switch audio in just a minute here. Monica, if you know the formula for this, A of t equals P times 1 plus R to the T power. So you know that the P value there is the 300 is the principal. The rate is 3%. And then the time is 3 years. It's always time measured in years, so that's 3 years. And so if the time changes to 1 year, then it's going to be, the thing that changes, that's really a 1 then at that point. I will try to, I think I'm having some audio problems, so let me see if I can fix that. Just a second. It shouldn't take too long.
We're going to have Jeff call in on his cell phone. Hopefully this clears up the audio issues. Thanks for sticking with us. Tom, if you'd like to fill in the dead air time with giving out Pez, you can. I think that some people might appreciate that.
Yeah, I think we have 130 some people. I only have about 50 Pez, so.
Maybe we could, give.
There you go. There, Jeff, you back?
I think we are back now.
Okay.
Sorry about that. So y'all have been teaching remotely. You know that these kinds of things happen when you teach remotely. I know you've had probably some experience this year. Our school's been kind of hybrid, and so I've definitely done my share of remote teaching this year. And you just have to you're gonna have to roll with the punches here. So I told you there's going to be some doozies. This one is a really interesting problem. Here, go ahead and try this one for about 30 seconds or so.
Hey, Jeff, I don't see your screen.
Okay, let me share the screen again. Thank you for alerting me to that.
There we go. Good. Thank you.
No problem. Okay, so this one, try this one. It's a doozy. And of course, the traditional method here, you're going to find the LCD, multiply really every term by that LCD. And it gets kind of messy, but you basically get a quadratic here. Factor that. And when students see x plus 2, very often, I would think that many students might just go ahead and choose the x equals -2 at that point. Tom, don't you think that would be pretty tempting?
Absolutely. Absolutely. Too many of them don't do the restricted values at the beginning.
Right. And this is kind of a new thing. I think about 5 years ago, they didn't have any extraneous solutions. That is an extraneous solution there. But 5 years ago, they didn't even have this. So this is kind of a new thing if you didn't realize they're really sneaky here. So the strong students are almost punished if they don't, realize, oh, like, I should probably check that denominator here. In fact, the strategy I'm talking about here is maybe glance at the answers and eliminate strategy. If you look at those denominators right away, you actually could cross out A and D as really not possible very quickly there. And so if I saw this problem and I knew A and D were gone, even though I could do the traditional method, I think I really might just try to plug in one of those answers, because at this point, you only have to plug in potentially 2 answers. And Tom, kind of like you were doing with the store command, I think this would be a good use of that. You could store 0.5, store it as X. or 1/2 as x, and then type it in. And you could type in, the left-hand side. By the way, if you didn't know this, on the new 84 on the E, if you hit alpha x, that's a fraction. A very quick way to get it. So you say 4x squared over x squared minus 4, and then minus, and then alpha x 2x over x plus 2. And you get negative 2/3, and you could, and then you could just type in the other one. So, whoops. So 1 over x minus 2. And you see that's also equal to negative 2/3. So we really, at that point, you knew the answer was either negative 1/2 or positive 1/2. And so there's really only one answer to check. And so if you know that going in, I feel like that's the method I would use. Tom, what do you think? Would you still use the traditional method, or would you think about just substituting in?
I did substitution, but isn't this this is a no calculator one, isn't it, though?
Oh, I forgot about that. So that's a good point. That's what that NC means. So we would have had to substitute in without a calculator here. So 1/2 squared over 1/2 squared, which isn't too bad. But yes, thank you for pointing that out. I forgot about that.
That'd be kind of nasty. Daniel made a good point. He said that if you eliminate A and D right away, it's a 50-50,
Yeah.
It's a 50-50 pretty quickly. So
yeah, so you could definitely do it this way as well. You got to be decent with fractions. But anyway, it's really hard to avoid fractions on this problem. Think about the algebra on this. The SAT is notorious for being, over half the test is algebra, and I think some of its algebra definitely bleeds into what I almost call like pre-calculus algebra. Pretty high level algebra. The other, another problem, I thought this was a really interesting one because I don't ask a lot of questions like these. I'm trying to think of a time I've asked a question like this in my class, and I can't think of one quite like this. So try this one. Take about 30 seconds and try it. So there's a lot of different ways to look at this problem. If you solve this kind of the traditional method, at least that's how I did it, you have to split it up into the positive and negative cases there. The negative case doesn't really work out. The positive case does eventually work out, so that's a lot of work, and you get x equals 4. I think I saw someone in the chat thinking, if you're going to test answers, I always try to test the easiest ones first. So if you're going to test a value in there somewhat quickly, I think, testing the 4 in there, I'm not sure how many of you did that, but it certainly seems like a lot less work to test the 4 and the 16 than it does to do the traditional method of solving there. And we could also think about solving this with our calculator as well. So if you haven't seen the new solver on the 84, it's pretty neat. So if you hit the math key and you scroll up, there's the numeric solver. And it looks a little different. I think in the past you had to solve solve the equation and set it equal to 0. And now you really don't. So I would type it exactly as it is. The left-hand side I would type as the first equation. So 9 minus square root of x. Whoops. Square root of x. And squared. And then in the second equation, on the right-hand side, it'd be parentheses 5 plus square root.
And those E's, I think, stand for expression 1 and expression 2, like not equations.
Oh, okay.
Yeah.
Yeah. And then you hit the soft key, kind of like Tom was talking about before, the OK key, which is the graph key there. And then you can put a guess in there if you want to. You can just hit the graph key to solve it. And it gives you one of the answers. It only gives you one answer. If there were more answers, the guess would tell me. So if I typed in, say, -100 here, it's going to find the closest answer. When I hit solve or graph, it'll find the closest answer to that. Wow. That's not what I expected. Wow. If I do 100 and hit graph, it'll find the close answer to that, which is 4, which is the answer I expected. I don't know why we got that other.
Well, it's using an algorithm, so yeah.
Yeah, it was having a little trouble there. But the solve command works nicely in that. And of course, a lot of these, I think for the SAT, I don't know if you feel this way, Tom, but a lot of things can be graphed to solve. And so if it's on the calculator section, you can just graph this is the other way of doing it. Just type in, 9 minus square root of x here. Squared. Oops, gotta put the parentheses in. And as your second equation, you would type in 5 plus square root of x squared. And graphing it, let's see if I hit the graph key. So, so I don't see them. Is that because they're so far zoomed out? So zoom out.
Oh yeah, yeah.
So you could, I guess I'd have to zoom out again. Once you see where they cross, they have to be in the viewing screen, I believe. Then you can go second trace 5. In this case, I think enter, enter, enter should work. And the intersection is 4 there.
Could you pull that off so we could see that better, Jeff? Pull that screenshot off into your. Yeah, there we go.
So, I mean, it only crosses 1.
And you can see and then you were getting that 49, which is what we got when we substituted 4, 7 squared on each side to show that.
Yeah, that's a good point. So the y value was the distractor there. So anyway, I thought that was a really interesting problem. Lots of different ways to solve it. But again, the idea of just plugging the answers is a pretty powerful way of solving things for sure. Sometimes I'm surprised by problems. This one really surprised me. I just want you to see it. And here's what I want to tell students, because some of my students are so thorough. They're very good students. They're good. They love their academics, and they will solve this all the way through. So many of my students will. And really, once you do first times first, 3x cubed times x cubed, and you see that that's 3x to the 6, I think at that point, what I tell my students, you should stop, and that's got to be the answer at that point. Because again, a lot of our students, I use this problem just to teach them, yes, you could double check, but usually on this test, we're so crunched for time, a lot of our students don't finish the math section on time. And so if we can teach them ways to, not do all the problem, just find the right answer as fast as you can, it's a little different than math class where I want them to thoroughly solve the problem. What do you think about that, Tom? Do you think students would continue going with this problem?
Well, absolutely. I think they would look at this and they would just multiply all 4 of those, and for sure. A couple people made a good suggestion: multiply the first terms and multiply the 2 second terms. And if you just do the 2-second terms, it still gives you C and D, so that you still have to do at least the first terms. But definitely don't have to do the middle term. Get the middle term.
Right. That's a good point. The middle term is completely irrelevant at that point. If you know the last term is -6x squared. So that's a good point. Think graphically. So this is just, when I teach my students in solving a system, try this problem for just a few seconds. 100 times, say 15 seconds. And what I want my students on this problem, I want them to recognize 2x and 3x are different slopes. So it's got to be one solution. This concept that slope will be different, it's got to be one solution if it's a linear system. If there's no solution, the slopes have to be the same, but the y-intercepts have to be different. And if infinite solutions, the slopes have to be the same and the y-intercept has to be the same. So really, it comes down to those three concepts. And so in a tougher question, I really want to end with this one right here, actually, just because it was such a good question. And this will be my last question. I'll give you a second here. Mike, I'll give it back to you in just a minute. But this question really mystified me when I tried it one way here. And I think our students would be tempted to solve this for x. And so if you get that, you get to this point, you say, well, 7 minus a is in the denominator. So if a was 7, this would be undefined. So I very quickly go, okay, that one's definitely true, but that only eliminates one answer there. And if you have this, I really was kind of stuck. I was like, well, I don't know. What can B be? So you really have to look at this differently, I think. If you kind of start at this and think about the slope and the y-intercept. So on this side, you'd say AX plus AB. So you would say, yes, A can't be 7, or A has to be 7 for this to have no solutions. But then we really don't want this to be 3. And if A is 7 and B is 3/7, that value there, we would really be adding a 3 there. So this really can't be true. It has to be true as well. And so I just thought it was a very good problem. They're really getting at this idea of thinking about it graphically. If our students have this kind of knowledge, as they can just draw on that, there's so many questions on the SAT that really you're drawing on that idea of the slope and the y-intercept, and thinking about it that way rather than algebraically solving it for x, and you kind of get to a stopping point there. So I really like that question, just to bring out that concept of thinking graphically about the slope and the y-intercept there. I think we are out of time, Tom.
Yeah,
this has been fun, though.
Yeah. Somebody asked you to go, can you go back to this thinking graphically slide for a second? Okay. No, the one after that says the one after that.
Oh,
there.
that one. Okay. Yeah. I really like this one because if students could think about, I think most students will think about that being a y-intercept of -3. But Tom, I don't know if you thought this way. I thought about that as an x-intercept of 3. Does that make sense?
Mm-hmm.
Because really it does cross. I mean, it certainly does cross at -3, but it also, if you think about that as like a solution, or it also crosses at 3 there, and then you see this one crosses at 3. You think, oh, the answer is 3. It's just a different way of solving that problem without actually graphing it on the calculator or anything.
Right. Okay.
Okay. Mike, you got it?
Yep, I'm taking it back right now.
Okay.
To receive a certificate of attendance, please click the link in the chat window. And also is a link for the documents that were used tonight. Included in that documents link is Tom's link for his bit.ly for all the documents that they created tonight. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Big thanks, guys. I'm excited to go into my classroom tomorrow, to my SAT prep class tomorrow, and talking about some of the things that I learned from you guys tonight. So thanks so much for everything you put together and shared.
It was fun, as always, Mike.
It was great.
And thanks, everyone, for joining us. Please stay safe, and we will see you back online, hopefully next week. Have a great night.